All right, guys, so if you went and took a look at the homework, you very well may have been overwhelmed. It's totally understandable because we didn't even get a chance to start dabbling in it. You'll feel much better about it today, although I gotta be honest with you, you might feel a little bit overwhelmed, but hear this. You know the math you need to know to be able to do all of this. The thing is now is you have to start making connections about what these questions are asking. You're gonna see all these questions on your quiz. We're gonna talk a little bit about how to use your calculator to do the heavy lifting on these. You do not have to take manual derivatives on this test. You will have a calculator. Your calculator takes derivatives really nicely. Thursday as of right now. Okay, I know that seems crazy, but we're going to go over 2 review days, basically today and tomorrow. And again, I think you'll feel much better after today. So we're going to jump to your book. We kind of left off maybe right on 107, but I'm going to jump to example 5. So if you want to do that on page 108, maybe. And let's take a look at how we're going to actually apply what we know. And you'll see we're going to be digging out of tons of what we learned from first 9 weeks and second 9 weeks. Everybody with me? All right. So first thing, projectile is thrown upward from the ground. I give you a position function. I tell you the initial velocity is 112. That's really not super needed in this because you could totally get that from this eventually. But I did mention it. It says if the vertical position is given by that, and sometimes they'll use H for vertical position like height or Y, because Y tends to move that way. But this time they just went with X. So you got to get used to seeing everything like this. But this is our position function. First question, can I find the velocity and the speed at those times? So how would I find velocity from this position equation? Take the derivative. So real quickly, my velocity function, so my v of t would be the derivative of that, which negative 32t plus 112. Now, I'm doing this manually, but if this is your test, you do not have to do this. I'm going to show you in a second how you can use your calculator to just jump straight to your answer, and you don't have to risk making a mistake. Now, this, not a high level of risk for a mistake there, but I'll show. So I would probably do this manually because it's quicker than plugging it in. But if the uglier that function gets, the more likely I am to use my calculator. And you'll see that in a second. So this wants to know the velocity at 3. So literally, I don't have to show all my math on a calculator section. All I got to do is plug that 3 in. Looking for this. And when I plug, where is it? When I plug that 3 in, I get 16. So if I get 16 when I plug the 3 in, doesn't that also mean the speed, which is the absolute velocity, is also 16? And then if I want to find the velocity at 5, I plug a 5 in. When I do that, I get negative 48. And by the way, what are the units of speed if I'm going feet in seconds? By the way, I'm sorry, if my position is in feet, but my velocity is feet per second, make sure you label this the velocity and the speed feet per second. Same thing here, feet per second. Now, what's the speed at 5? The speed at 5 would just be positive 48 feet per second. So hopefully that's not a big deal. If I give you a position equation, you take the derivative. Now, let me show you how to use your calculator on these. And again, I probably wouldn't do it on this problem because it's so easy to do it this way. But let me show you. I'll start with the 84. So if you have an 84, here's what you're going to do. So you're going to go to your screen right here, and you're going to want to take a derivative of your position. Now, if you're going to do this, you need to show your math, right? So in my calculator, I'm going to type something in here, but I'm going to write something a little bit more than that. So what I would do here is I would go math. If you hit the math button, which is right below your alpha key right there, hit math, and 8 is your numerical derivative. So I'm going to go math 8, and it creates a derivative formula for me, right? Now, my equation is in t. You're welcome to substitute x's for your t's, or you can use t's. If you ever graph them, you need to use x's. So I kind of out of habit use x's, but I'm going to use t's right here, even though they're a little bit, no, I'm not. I'm going to use x's because it's just too easy. So I'm going to put an x there, and then I'm going to type in my equation for my position. And my position equation is, what was it again? Negative 16 x squared plus 112x. And I'm going to come down there, and I wanted the position at, the velocity at 3. So I plug a 3 in there, and it takes the derivative at 3 for me and just spits out the 16 that I wanted. Okay? Now, I'm going to show you, now for me to do speed, it's no big deal, just make it positive. But what do I do to find the acceleration at 3 if I wanted to do that? It's a little bit tedious with this 84 because I have to take the derivative of the derivative. If you have an Inspire, there's a function for the second derivative that you just plug and it does it automatically for you. But here, I'm going to have to set this up a little. It's going to be a little nastier. So watch. I'm going to have to go math 8 for the first derivative at x. And then I'm going to go math 8 again and put another x in there. So I'm going to take the derivative of the derivative, and then I'm going to type in my function. So this is how I would do acceleration if it asked me. It didn't ask me, but if it did. Plug in my squareds plus 112x, okay? And then here's what you got to remember. I can't put 3 on both of these because if I put a 3 there, what this does is takes the derivative at 3 and gets a number, 16, and then it takes the derivative of 16 and spits out a 0, right? Because the derivative of a constant is a 0. So what you have to do is plug an x there, and then, so it takes the derivative of x and it's still a formula, and then when it takes the derivative again to get to acceleration, then you plug the 3 in or whatever number you want, and it would spit out that acceleration. Which makes sense because in gravity, it's negative 32 feet per second squared if you're in feet and seconds, and that's gravity. Are you tracking with me a little bit? So if it asked you acceleration, guys, you don't have to take the derivative twice. Now, on this one, I probably would have done it manually. It's just too easy. It's nice, simple power rule. But we're going to come to one in a second where it's not a nice, simple power rule, and I'm willing to bet that maybe a third of you, if not more, have forgotten the rule already. Some of you are going to remember it because some in the other class did. But just to check you, I'll say, all right, do it manually. What would you do? And a lot of you would have ended up missing it. And if it's a calculator problem, they don't even want to see the derivative manually. So even if you were close, you got, well, can I get partial credit? They're going to go, no, because I didn't even want to see it. I wanted the calculator to do the work. Now, back to velocity. On this question, it said velocity. What do you write on your paper? You have to tell the reader you know what you're talking about. So what you're going to do, and you can do it very simply, you can say, my velocity is the derivative of the position function. You don't even have to write it in there. Your calculator, you got to put it in there, obviously, to tell your calculator. But on your paper, if they've already defined this as x of t, just write x of t and say, sorry, if you're going to use t's all the way. Sorry. If you're going to use t's all the way. But all I have to say is the velocity at 3 is the derivative of the position function at t is 3. And that's all you have to say, and then whatever your calculator spits out. And we'll go over this countless times before your AP test, so you will get comfortable with it. But remember, guys, this is not just about writing an answer. You have to tell the reader you know what the calculus is. You have to do it. And if you don't do that, you're just going to end up missing half your points on any free response question, if not more. So you're literally telling them, hey, I know velocity is found by taking the derivative of the position. When the time is 3, make sure you got a 3 there and a 3 there, and I will get 16. Now, on the TI Inspire, I think it's a little easier, but it's a totally different process. So here we go. Here's your Inspire. All right. So I'm down there at the bottom of the page. If I want to find the derivative, I'm going to go menu. I hit menu. And look, number 4 is calculus. And almost everything works through the menu. You found that out if you have an Inspire. So hit menu and then hit the calculus button. and you want numerical derivative at a point. So I'm going to hit the number 1 because I want a derivative. And then here's what it says. What variable would you like to use? Well, it's really easy to change that to t because you've got the alphabet right there, right? It's not like you got to do a second function or anything. But x is fine, right? And then it says, hey, what value are you going to take that derivative at? At 3. So you plug a 3 in there, and then you go, well, do you want the first derivative or a second derivative? I want the first because I want velocity. And then all I do is hit enter, and it sets up. So it actually is a little bit maybe more difficult for this because it's a couple extra button pushes than just math 8, and you're right there. But you got it ready to go, and all you got to do is type your equation in there. So what was my equation again? Negative 16. I'm using x, so x squared plus 112x, and then just hit enter, and it spits out the 16. But here's where it's really nice. If I were to say, what's the acceleration at time 3, I don't have to do this double derivative garbage. I can just go menu, calculus, numerical derivative at 3, but I can just go down and hit that and choose second derivative and hit enter. And look, it's set up for the second derivative. So all I have to do is type in my negative 16 x squared plus 112x, and it goes and finds the second derivative for me without having to do that whole thing and remember to put an x first and then a 3 second. It just does it nice and neat. So that would be the acceleration if I had asked you that. You got with me on that? But please use your calculator when you're finding numerical derivatives if you have it. If you don't, well, then show your work on your derivative. But guys, you are wasting your time. And believe me, AP will give you horrific looking equations with really ugly processes. Sometimes it would be like, negative 2x to the x. We haven't even learned how to do negative 2x to the x. That's a BC topic. I don't know how to take the, I do, but you don't know how to take the derivative of negative 2x to the x. You only know how to do it when the base is a number to the x. So you end up trying to do it and you end up missing it when all you had to do was let your calculator do the work. So when you have a calculator, especially on this test, unless it's super easy, like maybe this one would have been, let your calculator do the math. All right. And again, what I would have written here, if it were me, just to make it really clear, I would have said, all right, what am I finding? The acceleration at time 3 equals, and I'm going to make that statement, except honestly, I probably wouldn't have typed that in there. I probably would have just plugged the second derivative of the position at 3 gives me the acceleration. Because I don't need to show AP every little thing. I just got to show them that I understand conceptually what I'm doing. Y'all with me? I hope so. All right, jumping back to our little problem here. All right, so this first question, I promise you it's going to be on your test, especially parts B and C. So part B, those of you that are in physics, actually, I'll take anybody's response in here. But those of you in physics, you probably already know this answer. But right here it says, how high will the projectile rise? Now, what am I essentially trying to find? I'm trying to find the max. If you wanted to use pre-calc, I could go, well, where does a max occur on a parabola? At the vertex. So if you wanted to, you could pull out completing the square, and actually do that. I have no desire to do that at all. And if I did do it, AP is not going to give me credit for the work, even though they probably should because they didn't specify to use calculus, but they won't. So all you would get credit is an answer. So using calculus, what do I know about when this projectile reaches the maximum height? Okay, but what do I know about thinking in terms of truth, but thinking in terms of and what she said, slope is 0 is definitely true. But thinking in terms of position, velocity, and acceleration, what do I know about any of those things? I don't know how high it got. I do know the acceleration due to gravity is probably constant. But what do I know about velocity right there? It stopped. If it stopped, my velocity is 0. I can go to the velocity equation, which I already know, and set it equal to 0. So, and I'm going to talk about it 2 ways again. Now, we already said that manually, I would have already found velocity, right? I would have found velocity, negative 32t plus 112. So all I really have to do is say, well, when it hits the high spot, the velocity is 0. So that's really all AP wants to see. And you can either say V is 0 or that is 0. Okay? Now, to solve this, because it's so simple, I'm going to solve it algebraically. But if I wanted to, I could graph that and find the places where it hit the x-axis, which would be when the velocity hits 0. I can do that. Super easy. I'm going to do it with a different problem now. Here, I'm just going to set it equal to 0, move that 112 over, divide by -32, and I get what? 3.5? Now, is that my answer? No, 3.5 seconds is what? The time it took to get to that maximum height. So how do I actually find the maximum height? Plug it back into the position function. So I go back and find the position at 3.5. And you don't have to show the math on that. Just plug it back in there manually, and you end up getting 196. We're dealing with feet. If I plug that back into the position. Remember how to do that, okay? Second question you need to definitely remember how to do. Find the speed when it hits the ground. Now, I already said yesterday, what is not the right answer? Oh, it's on the ground, it's got to be 0. I mean the instant right as it makes contact, the instant right before that, it was accelerating rapidly, getting faster and faster and faster and faster. If you're in physics, we are ignoring things like friction and what's that? Air resistance, which is like friction, right? But there's some point, there's a terminal velocity that you can hit with friction where it can't grow any faster, you know, no matter what. We're ignoring all that stuff. We're pretending like we're in a vacuum. There's no air friction, so I can speed up to the point of the speed of light if I had to fall far enough. So right here, I'm looking at this situation. What do I know about it hitting the ground? I know one thing. The position is 0, right? I don't know how fast it's going. I know the acceleration, but I'm not even dealing with the acceleration equation. So I know the position would be 0, so I'm taking the position function. And setting it equal to 0. And I could say this, but at some point I'm going to have to write that down. Now that also, if I wanted to, I can graph this. I can graph this and find the times, like literally find the x-intercepts. And we'll do that on a later problem. It's a little trickier, but I could if I wanted to. But because it does factor, it's already set equal to 0. It's pretty easy to factor out a t. In fact, actually a 16t comes out, but I'm going to take a t out in case you didn't see that. And I can see that when t is 0, or solving this, even if you don't see what divides out of that, right, you could still go, well, I know a 2 goes into that, all the negatives cancel, and that would give me 56, and an 8. At some point, you're going to go, oh, yeah, 8 goes into that, it gives me 7. So at 7 seconds and at 0 seconds, it hits the ground, or it's on the ground. So when did it actually hit the ground? It's 7 seconds. Now, there are some people in here right now that are going, well, I already knew that because it takes 3.5 seconds to reach the very top, then it's going to take 3.5 seconds to get down. Is that always true? I mean, if I take this pen and I throw it and I release it from here and it takes 3.5 seconds to reach the height, is it going to take 3.5 seconds to hit the ground? No, without friction, it's going to take 3.5 seconds to get back to that original height. Now on this one, where was I at time 0? At time 0, where was I? On the ground. So because I started on the ground, and it said that I was from ground level, but because I started on the ground and it took 3.5 up, yeah, it took 3.5 down. So if you're smart enough to see that and go, well, it started on the ground, it took 3.5 to reach the height. Yeah, of course, that's 7 seconds. At least say this. I totally understand you, but APCalc is going to want to see your math. So what they're going to want to see is at least this. They're going to want to see the position equals 0, right? The position is 0 at t is 7. And at least at that point, you're showing them that you know that this is about a position function hitting 0. If it's a calculator test. If it's not a calculator test, then you need to show the math. Are you seeing that? But here's the thing. What if I do this? Now what was my initial height, my initial position? 5. So now all bets are off. It's taking 3.5 seconds to go from 5 to the top. It's taking another 3.5 seconds to get back to 5 coming down, but I wanted to know to the ground. Well, those times are not the same. So if that's the case, you're going to be forced to do this math there, forced to deal with that, but we're going to show you that on a separate problem. Okay, what about this? Okay, let's look at this problem. I'm going to jump around a little bit, though. Here's a height problem. It says, how long did it take the rock to reach half the maximum height? Now, wait a minute. First thing, half the max means I need to know what? The max height. How do I find the max height again? When the velocity is 0. So if that's position, then my velocity function would be 24 minus 1.6t. And again, I'm doing this problem right here. I would set that equal to 0. I would solve it. And you have a calculator, so this shouldn't be that big of a deal. But even if you didn't, I could divide 8 in that and 8 in that, 0.2, and I get 30, 15. So 15 seconds, but you'll have a calculator. So it took me 15 seconds to reach the highest point. Now, how high did it go? If it took 15 seconds to reach that height, what was that height? What do I find? So h of 15, the height at 15 seconds. Make sure you label it, but you don't have to show all the math if it's a calculated question. So you plug 15 in, I'll go ahead and tell you it's 180 meters. Now, here's the next question. How long would it have taken to reach half that height? Now, the mistake a lot of people go is they say, well, if it took 15 seconds to get to there, then it's going to take 7.5 seconds to reach 90 feet. But is that true? No, because it's going a whole lot faster when I throw it. It's slowing down, right? So it was super fast the first half, and it's slowing down the second half. So if I want to know the time it takes, how long it takes to reach half the maximum height, I want the time it takes to reach a height of 90. So what do I do? 90 in the what? In the position. So I'm saying, okay, if the height is 90, how long did it take? And here's where I want you to take your calculator out. How would I solve that manually? Now, you should know this, but it would not be super pretty. How would I solve an equation like that manually? Now, hold on. When we solve by factoring, what would it have to be equal to? 0. So I can actually divide and multiply both sides by stuff. That's true. And if you don't like the decimal, I'd probably do that too. Like multiply by a 10 and I move the decimal, or multiply by a 5 and I can move the decimal, right? But to solve this, I would have to set it equal to 0. And this is not the right order, but I'm doing this for a reason. I would have to get it equal to 0. And you can look at that and go, oh, that's a quadratic. I can write it in quadratic form, but then I would have to either factor it, which is probably not going to factor nicely, or use the quadratic formula. So, and if it's not squared, if it's cubed, then I can't even do that. Please, when it is a calculator problem, set it equal to 0 and just graph it and find the intercepts. I want to know, when is t going to be 0? So if I just replace that with a y, I take this and replace it with a y and replace those with x's, I'm literally going to graph this equation and find the x values where y was 0, which is x-intercepts. So I'm going to go ahead and type this in there. I'm going to start with an 84. I'm clearing this out. I'm going to graph y equals, so y equals 24x, you don't even have to have it in the right order, minus 0.8x squared minus 90. So here we go. So I'm going to graph it in there. And again, I've replaced the 0 with the y. So what I'm going to do is graph this thing and see when would the x value, for what x values would the height be 0, the y be 0. I'm finding x-intercepts. So all I got to do is make a window that's going to see all of that. Now, if I just hit zoom 6 on a standard graph, I'm probably not going to see much. So let's think about what was happening. How much? It took 15 seconds to reach the height, right? Isn't that going to take another 15 seconds to get down to the bottom? Isn't that right? What problem are we getting? Said how long? It took 15 seconds to get the highest point. So if that's time 15 seconds, I'm going to make my window. So there's one intercept, which is great, but I don't see where it came back down. So what I'm going to do is stretch this out to maybe x is 30, or how about even 35, so I can make sure I get everything in. And then how high does it matter how high or low it goes? I mean, it went up to 180, but do I really need to see the whole parabola, or do I just need to see the intercepts? So if I only need to see the intercepts, I probably don't even need to change that. But if I want to see them, change those. Go up to 200 and graph this thing, and you can see the parabola. But again, all I really need to see is the intercepts. So all I have to do to find out is to go and do the calculate the zeros here. Do y'all know how to do that with the 84? Who has an 84 in here? 3 or 4 of y'all, 5 of y'all? Okay, so here we go if you've forgotten. I'm going to go, second calculate the 0. Now it tells me to do a left bound and a right bound. You can scroll, but it takes forever. Looks like it's crossing at 4 something. So I'm just going to go like left bound. I'm going to hit 3 and hit enter, and it puts a line on the left. And then for the right, I don't know, 8, hit enter. As long as they're on the left and the right, and if you don't get them on either side, redo it. Just do second calculate, do it over, and then guess, just hit enter. And there's your first time. So at 4.393, we always round to 3 decimals. That's where I hit 90 going up. And then I got to find 90 going down. So second calculate the 0, left bound, I don't know, maybe 20. Yep, that's to the left. Maybe 28. Yep, that's to the right. Hit enter again. And at 25.607, because I'm rounding to 3, that's when it hit 90 on the downward swing. Let your calculator do the math for you. Okay, we'll talk more and more about your calculator as we move on. Here's your Inspire. If you're Inspire here, I'm going to go to the graph. Okay, I already have it in there. So, but I would go to tab and I would type it in there, right there. And then once I have it in there, I'm going to go my window, menu, window settings. And like before, if you want to go like -10 out to 35 or 40, great. For the min, if you want to go like -10 up to 200 to make sure you see the whole thing, great. And you graph it and you see it. I just got to find the roots now, the zeros. How do you do that on this thing? Everything goes through that menu almost. So I'm going to hit menu. I'm going to hit analyze the graph. And there are my zeros again. I'm going to hit 1. But I think it's a little easier here because I have that little cursor. I'm going to scroll over here and click to the left. Come back, click to the right. And there's my 4.393 or whatever that was. And if you can't see it because it's, go grab it and move it so you can see it. And then I can do the same thing with this one, and it gives me 25.607. And you can see I've already done that one. But y'all with me? But guys, if you do the math manually and you plug it in the quadratic formula, you got to remember that AP is assigning points for people that don't need to do that. They're going, we don't need to do that. So I'm not giving any credit for bad quadratic. I'm not going to look at your quadratic formula and go, oh man, so close. 2 times 4 is 6. I mean, whatever. If you made a little error like that, they're not going to go, oh, they set it up right, because they're not giving credit for that. It's all about an answer and you describing what you're doing. So please know that you have your calculator. Please use it. And you do not have to do manual stuff all the time. Let's jump to something else. I want to jump to number 1 right here. This is on page 109. So this is in the homework. If you did the homework already, that's awesome. I'm very impressed if you were able to get through it. If you were not, I totally understand because we hadn't talked about much. So let's look at number 1, and I want to do this with my calculator. Okay? So it says a particle moves along by that velocity. What's the acceleration at 3? Well, if I give you velocity, how do I find acceleration? Take the derivative. Okay, so just to prove a point, somebody tell me what the derivative is. So what's the derivative of 7? 0. So I don't have to write anything. What's the derivative of that? So copy it down. The derivative of the blah, which would be times the natural log of 1.01. Now you can do that if you want, but then you're still going to have to do what? Find the acceleration by literally taking this and plugging it into your calculator with your 3 in the right spot there, your 3 in the right spot there, and you're going to have to do all manually. I'm not going to do that because I know that acceleration is what? The derivative of velocity. So on my paper, I'm going to write acceleration is the derivative of velocity. Sorry if I'm going to use a T. Stick with the T. At what time do I want? So all I need to write on my paper is this and whatever my answer is. Now, obviously, when I type it in my calculator, I'm not going to have this. I'm going to have to do the ddx and actually type in the velocity. But your calculator doesn't work for you. Are y'all with me on that? Y'all remember how to do that with both calculators? Or with your calculator? Math 8 or second or a menu calculus derivative. So make sure you can get there. I think when you do it, you get you get B when you round. But literally, like if you did it this way, right here on the right, and you forgot the ln of 1.01, so your answer's wrong, you realize you get no credit for this because you haven't told me anything. You haven't told me that you understood that acceleration was the derivative of velocity, which is all they want. They're giving you 1 point for that. Oh, he did know that, or she knew that, and what your answer is. And you got neither because you didn't do the derivative correctly. So they don't know what you're doing, and you won't get the right answer if you don't have that element. And for those who are thinking, I thought you said there wouldn't be any exponential problems if they weren't e's. If it's a non-calculator portion, you're right. You would never see this on a non-calculator section. But if it's a calculator section, they're literally expecting you to type it in the calculator. So I know there are people in here who will forget what I'm saying, and they will do it this way, and they will be correct, and more power to you. But I just think you're wasting time. That's so much simpler. And if you want to type that actual equation in there, you can. Write it in there on your paper, you can, but you don't have to. All right, now here's what's going to get a little bit more interesting. So please make sure that you are asking questions if I'm blowing your mind a little bit. So I'm going to go back. Do you remember when we did function graphs, and then I would say there'd be f, and then there'd be f prime, and then be f double prime, when we were sketching and doing stuff, and we were making connections with those, right? And do you remember the connections we made? We said what? When you remember this? If the function increase, how did I write it? I said if the derivative, let me write this. Didn't I always do it f double prime, f prime, f, or did I do it the other way? F prime, f double prime? Okay, so that's right. So let's look at that again. So what I said is, okay, if you have a function and it's increasing, then what do you know about its derivative? It's greater than 0. Well, with that in mind, then if I had a derivative and it was increasing, then what would you know about its second derivative? It's positive. And if I know the second derivative is positive, what do I know about the original function? It's concave up, right? Well, now think about this. This all is also true with not just f prime, and f double prime, but with position, velocity, and acceleration. So this is saying, hey, if you happen to have a position function, which there are a lot of variables for that, I'm just going to use x. If your position is concave up, then your derivative of position, which would be velocity, is increasing, and your derivative of velocity, which is acceleration, would be positive, right? And also, if my function is increasing, let's just call that v, or you could even say x. If x is increasing, then what do I know? My velocity is positive. So you can make these same connections from these two graphs, from these two relationships, because these are all linked together, right? But I'm hoping at this point you don't really have to write the chart out, and I think we'll be okay, but we'll see. So the first problem, let's just walk through it. And I really do think after we go through a couple of these, you're going to feel much better about doing your homework. And then I think we can iron out all the wrinkles tomorrow and we'll be ready for your test. We typically do the same thing. Everybody panics on day one. They feel a little bit better on day two, and they feel a lot better on day three. And then day four, they're good. So back to this. This is a velocity curve. So this is V. Okay, so I'm just going to label this V right here. It says there happen to be horizontal tangent lines at 0.4. So maybe that's going to be important. At 2 and at 3.6. Okay, and then it says there's actually points of inflection on this at 1.2 and also at 2.8. All right, I'm going to go ahead and label that 3.6 also. So let's see if we can answer some questions. Question 1, when would the particle be stopped? Now this is a velocity equation. So when is a particle stopped? When velocity is 0. So if this is velocity, where is velocity 0? 0, 1, 3, and 4. And my key accidentally does not say 4. I'll fix that tonight. So 0, 1, 3, and 4. Great. So I know I'm stopped there. Second question. Determine when the particle is moving to the right. What do we know about right movement? Velocity is positive. This is a velocity curve. So when am I moving to the right? When does velocity have positive values? 1 to 3, positive values. 4 to, I guess, infinity, although I'll probably make that more clear on the test. I didn't say anything about going to negative or positive infinity or having endpoints. So if I did, consider that. But we'll say 4 to infinity, positive values. And that would mean moving to the left would be 0 to 1 and 3 to 4. Now with me? And you might say that. If they say justify your answer, you could say, well, because velocity is greater than 0 on the interval 1 to 3, comma, 4 to infinity. Why do I know that? Because the velocity is positive. If somebody asked to justify. All right, so let's look at the next question. Determine when the particle is accelerating to the right. All right, let's think about that. When do I accelerate to the right? When, careful, this is not position. When the slope of velocity is positive, right? So if acceleration, I'm doing part C right here. If acceleration is the slope of velocity and I move to the right when acceleration is positive, on this graph, I have linked them together. And what am I looking for? Where the slopes of that are positive. So where are the slopes of this positive? Okay, so right here, I'm going to label these. From 0.4, which is right there, to 2, my acceleration is positive because acceleration is the derivative of velocity. And then also what? From 3.6 on to infinity, my acceleration is also positive because my slopes of the V curve are the same as the A curve. And then conversely, where would it be negative? From 0 to 0.4 and also 2 to 3.6. Are you with me on that? Okay, now let's put it together. where would the particle be speeding up? Now, speed is not velocity. So I want to show you 3 ways to find this. And I don't care which one you use, but remember, speed is the what? Absolute value of velocity. I don't have the absolute value of velocity curve at this moment, although we'll do that in a second. So what I'm going to do is another thing I know about speed. I know that you speed up when what happens? Did y'all hear that? You speed up when A and V have the same sign. Now, I already know that from here to here, V is negative. From here to here, V is positive. From here to here, V is negative. And from there on, V is positive. So looking at velocity and acceleration, where do you see the same signs? I see the same signs. V is negative, A is negative, all in there, right? Then I see V negative, A positive there. But then here I see A positive, V positive. Are you seeing that? A is positive, V is also positive. But here I see V positive, A negative. But look, it changes again, V negative, A negative. Right? And then, unfortunately there, A now becomes positive, V is still negative. But wait, picking up right here, A is positive, V is positive. So if I want to know when I'm speeding up from 0 to 0.4, from 1 to 2, from 3 to 3.6, and from 4 on. Y'all seeing that? And it might be helpful if you wrote the V and the A stuff right near each other, so you don't have to look up and down like this. And then obviously, if that's when I'm speeding up, I'm slowing down in different places. Now, let me show you something else. What did we say? What did we say the speed curve really was? And do you remember how to do absolute value of a function? What do you do? Anything below now is above. So let me do this. Let me just do that and that. And then I am going to completely ignore this part. So let's just say that's not even there anymore. Now, if these are speeds, where do you see speeding up? Look, I know I'm 0 here, so I'm speeding up there. I'm speeding up there, I'm speeding up there, and I'm speeding up there, right? Because I'm moving what? Upward. So if you want to graph the curve, there's an even better way. But if you want to graph it like this, you can go, oh, 0 to 0.4, 1 to 2, 3 to 3.6, 4 to infinity. I'm speeding up. Now, does anybody see what else you could do? Isn't this right here where I'm stopped, right, on the velocity function? So as I'm moving along, aren't I moving away from stopped? If I'm moving away from stopped, shouldn't I be speeding up there? So if I'm moving away from stopped, away from stopped, away from stopped, away from stopped, aren't those the same intervals that I've had in the last 2 situations? And then once I hit that min or that max, I'm moving towards stopped, towards stopped, towards stopped. So I do that a lot of times rather than think, if I have the graph, which a lot of times I don't have a graph. But if I had the velocity graph, I'm totally going to do that. And that got you through all of this problem. Let me jump to this next one because it gives you a different function. Look at number 4 on the next page. Now what did I give you? The position function. So according to this, the position starts at 1. This is the times on the bottom. It looks like I'm moving on, but these are all positive positions. So I guess I'm always to the right. But I am moving a little bit further and then back and then further. Let's just take a look. So first question, when is the particle stopped? This is position. Now we know a particle is stopped when what? When the velocity is 0. How is velocity related to position? The velocity is the derivative of position, right? And I want to know when that is 0. That's the statement you want to make. Don't just write the answer, because most of the time they're going to say, when does it stop? Justify your answer. Well, it stopped when velocity is 0, and velocity is the derivative of position, and this is position. So where is the derivative of this 0? Well, it told me I had horizontal tangents at 0 here, at 1 there, and at 2 there. So if the slopes are 0 there, doesn't that mean I'm stopped at 0, 1, and 2? Yeah? So at, and I don't, yeah, position at time equals 0, 1, and 2. Now, determine when the particle is moving to the right. What do we know about right movement? Positive velocity. What's the link between velocity and position? It's the derivative of position. So I want to know, when is velocity positive? That's moving to the right. Well, then I'm asking, when is the derivative positive? When's the derivative of this positive? 0 to 1, positive slopes. 2 to infinity, positive slopes. So at 0 to 1, 2 to infinity, assuming it went to infinity. Moving to the left, 1 to 2. Y'all seeing it? For the same reason. Now, throw it all together. 3, determine when the particle is accelerating to the right. I'm going to scroll up here a little bit. All right. It told me that I had inflection points at 1/2 and at 1.5. Okay, so at 1/2, it looks like I'm changing concavity, and at 1.5, I'm changing concavity. What do I know about accelerating to the right? Hold on, don't jump ahead. I know what? That acceleration would be what? Acceleration won't be concave. Acceleration will be positive, right? When acceleration is positive, I'm moving to the right. But what do we have the link between this and this position graph? You're jumping ahead of yourself, but you gotta make these connections. How is A linked to position? A is the what? How is A linked to this X? The second derivative? So if A is positive, that means the second derivative of X is positive. That's when I want you to say what you want to say, which is I'm looking for where the second derivative, where the X function is concave up, because that's where the second derivative is positive. So where is it concave up? 0 to 0.5 and 1.5 to, I guess, infinity. Are you seeing these connections, guys? I know I'm digging deep and bringing some stuff back. Okay, last question. When is the particle speeding up? What does speeding up mean? I'm increasing. It means what? Acceleration, velocity have same sign. So when I look at this, from here to here, what do I know? From there to there, acceleration is positive because its second derivative is concave up. Acceleration's negative. And you would have to go through there and look at slopes and concavity and match them up. Hey, see what you can do, guys. Try to get caught up as much as you can and bring in questions tomorrow if you have them. See ya. Any better?
They so funny to try to but they didn't move.
I would have
I have a picture, so you can just copy it.
neither of them could be like, I've done all of these things. Neither of them could be like, I will
Copy everybody.
What you got?
Just the first page, page 1.
Yes.
Oh, good, because I got the second.